Welcome friends, I have a project here for our discussion today which is titled Microgrid using PV and Thingspeak. We are in an era of renewable energy sources where the energy is produced from solar PV, windmills, geothermal, hydrogen fuel cells, likewise. In a conventional way, the power is produced in a power plants which is based on the coal or gas or diesel power plants and which is stepped up and transmitted to a very long distance where the consumers are located, and then it is being distributed to the consumers, industrial, commercial or domestic consumers. So the power losses which is happening or which is occurring in the transmission line is very high in the conventional power system. And there is another problem. The greenhouse gases or the pollution emitted from these power plants are very high, which is to be reduced or which has to be removed. So we need to have a energy source or energy production which should be clean and which should be sustainable. And also it should not have much losses in the transmission kind of things. So there are clear objectives that we need to reduce the pollution, we need to reduce the losses, and the fossil fuels may not survive or may not available after few years, maybe 50 years or 100 years. So we need to find an alternate energy source as well. So these are the objectives. When we are coming into the non-conventional or the sustainable energy sources, the sustainable energy sources are available plenty. Either it may be a wind or it may be of solar or it may be a geothermal or hydrogen fuel. So it is available plenty. So we need to have an efficient and effective system to convert these renewable energy sources into electricity, and we need a system to monitor the production and utilization of this power. So there were the microgrid concept in coming into picture. So the microgrid means there is a power production and the load in the system, but it is not a huge number, it is a small number of consumers with a lesser size production, and the distribution takes place there, and mostly there will not be any long transmission lines so that the power losses can be avoided. So either the microgrid can be a standalone system or it can be connected to the utility grid as well. So if it is a standalone system, the system should be capable of producing enough amount of power to the required loads and it should manage it effectively. In case if the microgrid is connected to the grid, so if you have the power production large enough, it can utilized by the loads, and if the surplus power can be transmitted to the or fed back to the grid. In case of deficit, you can also consume the power from the grid or the utility grid. So this is the concept of microgrid. If you see the conventional power system, as I told you earlier, it may be a power plant fed by the fossil fuels, or it may be a power plant from the solar or the wind farms, and this power generation takes place from the far away place from the consumer. This power production, once it is done, then these voltages are stepped up to a very high voltage and transmitted in the long transmission line to the consumers. The consumers may be located in a village or it may be a metropolitan city. So this energy is transmitted for a long transmission lines, and the power losses are very high in the transmission line. And the other problem, as I told you, these fossil fuels produce a lot of pollution and it is depleting in nature. So we need to have alternate sources. So with this objective, when we are coming into the microgrid concept, so the grid is still there, so it is producing the power, but the renewable energy sources are also available at the consumer locations. So these consumer places, the microgrids or the small energy production plants, is trying to feed the load as much as possible, so that the loads are not taking the power from the grid, so that the power losses in the transmission line can be reduced. In case of the deficit, the power is being taken from the utility grid. In case of the surplus, it can be fed back to the grid as well. So by distributing the power production at required places, the losses in the transmission line can be reduced. And the other benefits is like, these are renewable sources, so it is available surplus, and also it is not producing much pollution. So this is the advantage. The same thing if you see the microgrid concept. So there is a grid, either it can be connected to the microgrid, or it can be isolated. So if it is isolated, it is called islanded concept. So where the microgrid itself produce, and then it feeds the load. Enough amount of power is being produced here. So it can be at different sources. We have solar, wind, and generators. Okay, so this is a diesel or any kind of a generator in case of backup, or you may have a fuel cell. So the power is being produced from the solar PV or the other methods, and it is being stored in the battery backup, and this battery backup power supply can be used for producing the hydrogen fuels or the hydrogen gases, so that it can be utilized in the night time to produce a high amount of power, which is when the light is not available for the solar PV. And also in case of peak loads, so the hydrogen fuel cell can meet the demands and things like that. So this is a microgrid concept. So in case if it is not islanded or if it is not isolated, so we can switch on the grid also. In case of deficit, it can take the power from the microgrid, from the utility grid. In case if you have surplus, also you can feed back. So this concept is called as prosumer concept. So the consumers now becoming a prosumers, so they produce as well as consume. So this is another picture which explains the microgrid concept. So where we have the microgrid has a different energy sources, renewable energy sources, generators, and things like that. And then the energy flow is taking place from the generator and renewable sources, and from the controller it goes to the storage place like batteries, and then also it feeds to the residential vehicles, electric vehicles, commercial buildings, all those things. In case if the power is not enough amount of power is not produced, you can consume from the utility grid. In case if you have more, then you can also give to the utility grid. So this is a energy movement in a microgrid. So now we will come to our project, so which is going to serve the concept of microgrid. So the objective of this project is to have a system which is going to monitor the power production, and it is also going to monitor the load in the consumer side, and based on that it is going to take a control actions, and it is also connected to the internet, and so that it will feed all the data of the system to the cloud server. From the cloud server you can take the data and analyze, and you can have predictions and predictive maintenance, and then you can have a load predictions, things like that we can achieve in this system. So the block diagram says we have a solar panels, so we can use any energy source here. Instead of a solar panel, we can have a wind source, or we can have a hydrogen fuel cell, or it may be a hybrid energy system. So we can have the energy source here. It is connected to the protective devices, the isolators and fuses and surge protective devices, things like that. And then we have a charge controllers to convert this energy, whatever is coming from here, to the chargeable pattern. So this charge controller controls how much current and voltage needs to be given to the battery in an optimal way. And then from the battery is the storage device which stores all the energy which is coming from the energy source, and then it is connected to the inverter, and from the inverter it is connected to the load through the relay unit. So this relay unit plays a very vital role. So this is the unit which is going to isolate the load and the energy source in case of a deficit. So here this particular system is going to work as a islanding concept. So this is not going to be connected to the grid, so it is fully dependent upon the energy which is produced from the solar panels or the energy source what you have. So it is not going to be connected to the grid, so that it is not fed or it is not going to consume the power from the grid. So we need to continuously monitor the battery voltages, and then so that we know that how much time it will feed the loader, whether it is full or empty, or it is partially charged. So we must continuously monitor this, and accordingly the relay should take the action. In case of any problem like over voltage, under voltage, or over current, or frequency variations or power factor variations, also the same relay will isolate the load and then from the source. So this is achieved by having the energy monitoring sensor, which will monitor the power, voltage, current, and frequency, power factor, all these parameters of this supply which is coming to the load. And from the battery, also we have connected some sensing devices, battery monitoring system, and it is connected to the Arduino. So this Arduino is nothing but our NodeMCU, so that is ESP8266, and this also connected to the Thingspeak server using the online monitoring system. We can monitor the data, and also you can fetch the data for future prediction and big data analysis, things like that. And the sensor unit will sense the required things like temperature, humidity, and all the other parameters whichever required, and display unit will show the values at present what is available from the system. So this is a cleaning system. The cleaning system is used for cleaning the solar PV in case of dusty, windy places. So we need to clean the panel for effectively producing the energy from the solar light. So this cleaning system is going to have a standalone Arduino, and it is going to have a motor to connect to the brushes which will roll on the panel and clean the system, and the sensors are used for controlling the movement of the motors so that the brush movement can be controlled, and timing unit is used for controlling the frequency of cleaning the panels. So it may be early morning one time and evening one time, or it can be if the more dust and more dusty place or uncleanly place means we can have a more number of frequency for cleaning the solar panels. So this is the circuit diagram here for our project. So solar panel is connected, though we have more panels, but I have shown here only one panel. We have a DC isolator, and from the DC isolator we have connected it to the fuse box, and from the fuse box it is connected to the solar charge controller. So we need to have a such protective devices as well, which is not shown here. When you have a the more number of panels which is connected to your house to produce more electricity, it is better to have a surge protective device, that is SPD. In case if you have a doubt on the SPDs, please watch a video which I have placed for SPDs for connecting solar panels, which is also available in our channel. So the output of this fuse box is connected to charge controller. The charge controller is a MPPT type. Actually here it is shown PWM type, but we have implemented a MPPT type charge controller, so which will optimally get the power from this PV, and the output of this charge controller will be fed to the battery, and from the battery it goes to the inverter unit. From the inverter unit, again from the AC side we have a protection, RCD and MCBs are there, and from the MCB output it goes to the relay. From the relay it goes to the load, and when it is connected to the relay, so that means when the load should be connected, when should be isolated, will be decided by the relay based on different conditions, as I told you earlier, battery level and then the fault conditions and things like that. So based on this, the controller is going to take a decision. So when the relay should be on, when the load should be connected, when the load should be disconnected. In case if you have a sophisticated system, we can have 2 or 3 relays. So one relay can be connected to connect only the lamp and fan kind of small loads, and the other relay can be used for socket outlets and kind of medium sized loads, and the third relay or the fourth relay can be used for connecting the AC, water heaters and things like that, based upon the availability of the power in the battery. So we can switch on or switch off the loads accordingly. So we have also energy sensor to monitor the various electrical parameter in the AC side, like voltage, current, frequency, power factor and different things from the AC side. So this is PZ EM04T. At last we have also the LCD to show all the values which is being measured and displayed here, and then we have voltage sensor to measure the voltage of the battery, and DHT11 for measuring and monitoring the temperature and humidity of the ambient condition. So this is the circuit diagram, and the code, when the code is concerned, I will just go through it. So first we need to include the header files related to the components which I have connected. So we have connected liquid crystal which has I2C configuration, so which is 20x4 size liquid crystal. So this is the header file for that, and for the energy sensor PZTM004T version 3 header file also included. And for the Wi-Fi ESP8266 Wi-Fi we have used, so we have utilized the header files for that. And then for Thingspeak we have included also Thingspeak header file here, and also we have the SSID and password, so which I have not shown here. For your project and your SSID and password, you can paste it over here. Include DHT11, and this is for DHT11, and some variables for storing the data and for the manipulations or the calculations which we have used. And the channel number, Thingspeak channel number is given here, and API key is also given here. And as I told you a little earlier, in case if you want to have a separate relay system for a different type of loads and a separate energy monitoring sensors, we can have 3 different energy sensors which I have shown here. This is for one, and this second, and this third one. So all are used soft serial. So based upon the requirement, you can use either 1, 2 or 3, even 4 energy sensors also can be connected. Since it is not hardware serial, it is only software serial, we can connect them to any digital pins, even for Arduino Uno or whatever the Arduino you are using, you can utilize them and you can connect them. And this is for the setup point of view. We have baud rate for the data transmission, and the SSID and password will be getting from here, and remaining things are for the LCD and serial monitor, things like that. We have to begin and we have to initialize the setups. In the loop, first we need to the first important thing is the battery monitoring, because based on that only it is going to decide whether the system is going to connect the load or disconnect the load. So first read the voltage of the battery, and then the battery voltage monitoring. So we have used the battery voltage monitoring sensor, so which is having the formulas. So if you have any doubts about this voltage measurements, also I have placed a video for this, please watch that video. So first read the battery voltage and do the calculations, and based on the calculations we are going to take a decision here if else condition is written here. And also here get the humidity and temperature from the humidity sensor. So this is for the humidity and temperature sensor. Again, this part also I have uploaded a separate video for humidity and the temperature in our channel itself. If you have it, please go through it as well. And when it comes to PZTM004T also, I have 2 or 3 videos related to this sensors, how to measure the energy and the power and things like that. I have placed a video. If you are confused in this bigger program, you can see that smaller program to understand only those concepts like DHT11 or the voltage measurement and power, this one PZTM004T. So based on that you can understand, and then you can come back to this program so that you will understand in a clear way. So we have 2 conditions which voltage, that is V input, is if it is greater than 12.4, that is board battery voltage. If it is greater than 12.4 voltage, so the system will start working. So that means if the battery is fully drained, from there it is charging. While charging, it should go at least 12.4 volt, then only it will start discharging to the load. So these values can be fixed as per your convenient, and while it is draining, it will go until 11.9 volt. Until 11.9 volt it will allow. So if the voltage is going less than 11.9 volt, it is going to disconnect the load from your battery. So as I told you, this is only I have used only one relay and one load. In case if you have multiple relays and connecting multiple different type of loads, we can have different values, 11.9 for AC and 11.9 for lighting and fan, and you can have 12.2 or 12.3 for socket outlet, and 12.6 or 7 for AC and water heater, like that. So we can have different values to control or disconnect or connect the different loads. So this is the part where you get the energy, voltage, current from the energy sensor, that is voltage, current, power, energy, frequency, power factor. Once we get all these data, we are going to display it in the LCD. So these all lines related to LCD where we are displaying the values. And we can also have the second energy sensor. So as I told you, we can have 2 or 3 energy sensors. So this is for the second energy sensor. Still, since I have used only one, I am not going to print it anymore. So this is not needed. So just for your information, I am just keeping it here. So if you are using the second energy sensor, then we will use this one. Otherwise, no need of this. And finally, we will upload those data to the Thingspeak using these lines, Thingspeak dot write field and channel number, voltage, and things like that. I have a for loop so that it will paste the values continuously. And these data, what are the data you want? Voltage, current, power, and we have V in, it is a battery voltage, humidity, temperature. All these values will be displayed in the Thingspeak. So I have a free channel only. I am using in the Thingspeak, so I can upload up to 8 fields or 8 data in the Thingspeak in a channel. So these are the data will be uploaded, and when you fail this condition, so if it is less than 11.9 volt, then here the else condition works. So it will turn off the relay so that the power will be shut down. So this condition can be, I have shown only for the battery voltage. You can also include other conditions like if the voltage is lesser, that is like a 210, 220 volt, or if the current is more than 5 or 6 ampere or 10 ampere, whatever it is. You can include many conditions to disconnect this particular load. So instead of else, you can write if else or other conditions. So you can write various conditions. If the power factor is 0.8 or if the frequency is 49, you can also remove, or you can open the relay so that it will disconnect the system. So that's it about the code, and let us see the implementation, project implementation. Sorry, actually while shooting the video I have taken it in this way, so actually it should have been in the horizontal way. So
this
let
is
us
our
see
hardware setup where we have the solar panel output coming to the.
So here we have 2 parts. One is for DC and another one is for AC. So for DC I have isolator, and I have a fuse box. Actually this is not isolator, this is RCD only, but actually speaking we have to connect the isolator, and also if we have a SPD, we have to connect the SPD as well. So I have here RCD, but it has to be replaced with the isolator, and we have fuse box here. From the fuse box it is connected to the charge controller. From the charge controller it is connected to the battery and
RCD,
other things.
RCD output is connected.
So this is fuse box.
From the fuse box,
and this is our charge controller. This is the MPPT charge controller. It is not PWM charge controller, it is MPPT charge controller, so which is more efficient than PWM charge controllers.
And from the charge controller we have connected the output to the battery unit,
and then we have a battery unit and an inverter here. I have 2 batteries connected in parallel way. So 12 volt 100 ampere hour gel batteries, we have 2 batteries here connected in parallel. In case if you have a high voltage solar input, that is like 24 volt or more than 24 volt input from the solar, then we can connect these 2 batteries in series. And also my inverter is 12 volt inverter, 12 to 240 volt inverter, so that's why I have used 2 batteries connected in series parallel, so that it can produce more, it can give more amount of current rather than voltage. So this is a pure sine wave inverter, which is also 1000 watts, and which can give up to 240 volt. Mostly it gives 220 or 230 volt, and 100 watts load can be connected. 1 kilowatts load can be connected.
Sine wave inverter, and the inverter output is connected to the
coming back to this AC side, from the inverter, the power is coming to this RCD, that is residual current devices, and from there it is connected to double pole MCB. From the double pole MCB it is connected to the PZ-EM004T, and it is also connected to the load. It is also connected to the load through the relay module, which I have shown here. So this relay module, since I have a small load here, I have used a small relay. If you have a bigger relay load, either you use a bigger relay size or you can use a contactor. So use this relay, the output of this relay you can connect it to the contactor so that it can control high amount of load current. And this PZ-EM004T having a current coil, also the potential. So from the potential directly you can take from the MCB here, and it is connected to the potential point, and these two wires which is coming from the current transformer, which is connected in the wire which is going to the load. So this is the load conductor, the current conductor which is connected to the load. So there I have connected this the current coil. So it takes the input of current as well as the voltage, so that it can calculate the power and frequency, power factor, everything using this PZ-EM004T.
Devices, we have RCD here and double pole MCB here, and the output of this MCB is going to the load through the current sensor, and the potential is also given here. So this energy measurement sensor.
So the PZ-EM004T is also connected to the Arduino using RxTX pin. So this RxTX, as I told you, I have connected with the software serial, so that any number of PZ-EM004T can be connected in the digital pin itself. No need of actually any analog pins or any RxTX pins requirement. So you can connect in any digital pin itself. So this is our NodeMCU, where ESP8266 is inbuilt in this particular module, which takes the data from the sensors and things like that. It do the calculations and also it uploads the data to the Thingspeak server.
The NodeMCU is going to send the data to Thingspeak server,
and we have here other sensors here, which is having a DHT11, which is going to measure heat and temperature and humidity, and then here this is voltage sensor, which is going to monitor the battery level of our system, and then we have a small power supply which will be converting the 12 volt DC into required 5 volt, so that it can be fed to our LCD and these sensors, and even for our Arduino.
Sensors like temperature, humidity measurement sensor we have here, and there is a chair, and then we have.
So this LCD shows the value of the voltage which is coming from the solar. So and it is also showing the battery voltage 12.4, humidity 55, temperature 27, voltage at the AC side 225 volt, and power utilized from the load is 16.8 watts, current is 0.08, and frequency 50, and power factor is 0.99. So these are the current values which is being in the system. And if you see the DC side, actually I have not shown the solar voltage, because this display is showing that voltage. So it is 12.2 volt from the solar panel, and 0.1 as a charging current here. So this 0.1, why? Because we actually my batteries are fully charged, and also I have used only a small solar panel for the demonstration purpose. So if you have a bigger panel and the batteries are charging fast, so that means the current will also be increased, and based on the sunlight the voltages also can be different.
AC voltage, power factor, frequency, current. This is our
this is our load.
The same data will be uploaded in the Thingspeak server.
And in the Thingspeak side, we have various parameters displayed in the Thingspeak graphs. So here you can see that there is a load voltage, load current, load power, battery voltage, and humidity, temperature. All the values are being uploaded to this Thingspeak server, and it is showing us a graph. So these data can be fetched for the future analysis. Also these data can be connected to MATLAB, so for analyzing the values what you are getting, and so that it can be used for future load prediction, and also it can be used for predicting the maintenance of the devices, and also it can be used for prediction or the forecast of the ambient conditions like temperature, pressure, and things like that. So these all can be done in the software side, either using MATLAB or any other machine learning algorithms also can be used for make the system more efficient, and also the artificial intelligence plays a very vital role to make the devices smart.
You can see there is data.
So you can see here export recent data. So that means this data can be fed to the MATLAB, or it can be taken to any other software so that the data can be analyzed, and the predictions can be done using fuzzy logic or any other machine learning algorithms.
Less than a minute ago it is updated. So this is the values.
So this is actually the current data. So trying to show the values. Sorry about the video quality actually.
So this is the panel.
So this is the solar panel. Actually, it is a very small solar panel. So actually, we have a grid here, a small microgrid, which is connected to our loads. So I don't want to disturb the system. That's why I've connected a small solar panel here for our system demonstration.
You can see the small
So
panel,
this
not the big
output
one.
is taken through this wire, and it is connected to our system. Here using this cable, it is connected to our system.
It is connected to
PV input.
the RCD and other active devices.
And these are the values at present. These are the values: battery voltage, humidity, temperature, all these values. Thank you, friends. I hope you enjoyed the video, and if you are trying to implement the project, in case if you need any help, you can ask me. I will clarify. In case if you need a code, and I will paste the link in the comment box, you can take the code and you can implement this. Thank you again.